Hello everyone, this is Varshini, a student of Stevengishwara College of Engineering, pursuing BE in Computer Science and Engineering. In this presentation, we are going to discuss about the subject Applied Physics for CSE stream. Topics are Principle of Complementarity and Wave Function and its Properties. And the contents are Introduction, Principle of Complementary, Dual nature of light, wave-particle duality in quantum mechanics, and applications. Introduction to wave function and properties, Schrödinger equation, superposition and interference, wave-particle duality, wave function collapse, normalization, uncertainty principle, and applications of wave function. Principle of complementarity. Introduction to the principle of complementarity. The principle of complementarity is a fundamental concept in biology and physics. It states that certain phenomena are best explained by considering both the particle and wave nature of matter and energy. This principle was first introduced by Danish physicist Niels Bohr in early 20th century. And the statement of principle of complementarity, Bohr stated as in a situation where the wave aspect of a system is revealed, its particle aspect is concealed. And in a situation where the particle aspect is revealed, its wave aspect is concealed. Revealing both simultaneously is impossible. The wave and particle aspects are complementary to each other. Dual nature of light. Light can exhibit both wave-like and particle-like properties. The wave nature of light explains the phenomena such as interference and diffraction. The particle nature of light is demonstrated through the photoelectric effect and the emission of discrete packets of energy called photons. Wave-particle duality in quantum mechanics. In quantum mechanics, all particles can exhibit wave-like and particle-like behavior. This duality is described by wave functions, which represents the probability distribution of a particle's position or energy. The behavior of particles is described by the Schrödinger equation, which combines both wave and particle aspects. Application in atomic structure. The principle of complementarity is essential in understanding the structure of atoms. The wave nature of electrons is described by atomic orbitals, which represents the probability of finding an electron in a specific location around the nucleus. The particle nature of electrons is observed in their discrete energy levels and emission or absorption of photons during electronic transitions. And the conclusion of principle of complementarity. The principle of complementarity underscores the importance of considering both wave and particle aspects in understanding the fundamental phenomena. It provides the framework for explaining the behavior of matter and energy at both microscopic and macroscopic levels. This principle continues to shape our understanding of a natural world and drives advancements in various scientific fields. The next topic is wave function and properties. Introduction to wave function and properties. The wave function describes the behavior of waves in quantum mechanics. It is the mathematical function that contains information about the particles, position, momentum, and energy. The wave function is represented by the symbol psi and is used to calculate the probabilities. Schrödinger equation. The Schrödinger equation is a fundamental equation in quantum mechanics that describes the time evolution of a particle's wave function. It is a partial differential equation and relates the wave function to the energy of the system. Solving the Schrödinger equation provides the information about allowed energy levels and corresponding wave functions. Properties of wave function. All measurable information about the particle is available. Size should be continuous and single valued. Using the Schrödinger equation, energy calculations become easy. Probability distribution in 3 dimensions is established using the wave function. The probability of finding a particle, if it exists, is 1. Superposition and interference. The wave function can be in a superposition of states, meaning it can exist in multiple states simultaneously. When two or more wave functions overlap, they can interfere constructively or destructively. Interference affects the probability distribution of finding the particle at a certain position. Wave-particle duality. The wave function represents the wave-like nature of particles in quantum mechanics. It describes the probability of finding a particle at a specific position. The wave-particle duality suggests that particles can exhibit the both wave and particle properties. Collapse. When a measurement is made on a system, the wave function collapses to a single state. The collapse of a wave function is a probabilistic event and outcome is determined by the measurement process. The collapse results in the definite value for the observed property of the particle. Normalization. The wave function must be normalized, meaning its integral over all space must equal to 1. Normalization ensures that the probability of finding the particle somewhere in space is 100%. By normalizing the wave function, we can calculate the probabilities of different outcomes. Uncertainty principle. The wave function introduces inherent uncertainty in measuring certain properties of a particle. The Heisenberg uncertainty principle states that there is a fundamental limit to the precision with which a certain pairs of a properties such as position and a momentum can be known simultaneously. The uncertainty principle is a consequence of wave-particle duality. Applications of wave function. The wave function is central to many areas of physics, including quantum mechanics, quantum field theory, and solid-state physics. It is used to determine the allowed energy levels and wave functions of particles in various systems. The wave function provides a powerful tool for understanding and predicting the behavior of particles at a quantum level. Finally, the conclusion of wave function. The wave function is the mathematical representation of a quantum system describing the probability distribution of a particle's properties. It satisfies certain mathematical properties such as normalization and unitarity. The wave function is a fundamental concept in quantum mechanics with applications in various fields of physics and technology.